Hi gang, this is section 8.4, which is more multiplication properties of exponents. So we're going to go power to a power. So instead of just multiplying across this way where we added, we're going to raise a power to a power, and I'll show you how to do that. This top part is a review of section 8.3. When you multiplied x cubed times x squared, the long way of doing it was writing it out, and you get x to the fifth power. Okay. The short way was to add them together, and you get x to the fifth power. Again, you keep the base. This section 8.4, we're raising power to a power. So again, here's the long way of doing it, and then I'll show you the short way of doing it. The long way is to rewrite it out twice, where it's x cubed times x cubed, because it's x cubed squared. And now I would write it out again. There's 3 of them here, and there's 3 of them here, and you get x to the 6th power. Okay, the shortcut way, if you're adding it this way, on this way you can actually multiply it to become x to the 6th power. Okay, here's a couple more examples. If I have something like this, the first one I want to do, I want to multiply this, so I get x to the 5th times x to the 12th. And now I got to do what we did over here. If I have x to the 5th times x to the 12th, I need to add my exponents, and I get x to the 17th power. Okay. So I kind of did one from each section. I had to go power to a power, and then I had to add the exponents there. So over here I got a double one, so I'm going to multiply these two. So I get x to the 21 times x to the 10th, and I'm going to add them together since I have the same base, and I get x to the 31st power. Okay. Here's another one where I'm going to do these two, and I get x to the 18th, y to the 32. And since they are different variables, I cannot combine them together. I just leave it as that. Here's a couple more different type of examples. Now, in this first case, all I had was a simple variable inside of the parentheses. Now over here, I put numbers inside them as well. So again, I'm going to do the long way over here, and I'll do the shortcut way over here. So the long way is to rewrite it out twice. Since it's 2 of them, you rewrite it out twice. And if you remember, we put the numbers in front, so it's 3 times 3, and then x fifth to the 5th times x to the 5th. And this became 9 x to the 10th power. Okay, the way you would do it shortcut-wise is you distribute this in to both of them. So this would just become 3 squared, and then x to the 10th, because I'm multiplying it. The way you can think of it too is there's an invisible 1 here, so 2 times 1 is 1. And then I get 9 x to the 10th power. So again, they're the same. This one is a little different. I wanted to show you this with a negative number in here. So when we rewrite it twice, I get negative 2 times negative 2, and then x to the 8th times x to the 8th. When I do negative 2 times negative 2, it becomes positive 4 x to the 16th power. I wanted to show that because when I distribute this in, if there's an invisible 1 there, you cannot just say negative 2 squared x to the, and distribute this into the 16th. Because this would come out to negative 4 x to the 16th, which is wrong. Okay, we did it here. So what I'm trying to show you is when you distribute this in, you have to put parentheses around this. So we end up with a positive 4. Okay, so be careful on this, and I hope you're watching this video to show when you distribute to a negative, when there's a negative in there, make sure you use parentheses around it. If this was a odd number like a 3, then it would still come out to a negative 8 if this was a 3. Okay, so just be careful. If it's an even number, it's going to cancel out and become a positive. The negatives will cancel out. Here's a few more examples. So now I have a 2x and a y in there. So what I do is I distribute this in. If you want to put in 1 there, you can. And it becomes 2 to the 3rd, x to the 15th, y to the 9th. 2 to the 3rd is 8, x to the 15th, y to the 9th. And now you are done. Okay, I wanted to do a couple with negative exponents. If there is a 1 here and I put it in, I get 5 to the negative 2, x to the negative 6. And if you remember, you cannot leave negative exponents. You need to drop them down. Okay, So circle them and drop them. Circle them and drop them. I leave a 1 on the top. I'm left with 5 squared x to the positive 6. Okay, and then the 5 squared can just become 25. Okay, and then here's another one, and I see the glare, so I'll switch inside. So here's another one. I'm going to distribute this in only to this one. Okay, so I'm going to write the 7x to the 5th, drop that straight down, and then this becomes x to the negative 9th. Okay, now I add them, 5 plus negative 9, so that becomes 7x to the negative 4 power. And again, now I want to drop it down, but I'm only going to drop down the x. So when I do this, I get 7 over x to the positive 4 power. Okay. So we're using sum of tonight's where you did power to power, sum of 8.3 where you had to add your exponents, and then sum of going back to 8.2 with the negative exponents, dropping it down. As a hint, I want you to remember, don't just do this and put it over 1 and drop it down. That makes things difficult. Add them up first on the same line, and then move them if you need to. Okay. Here's a few more just to help you guys out some more. So when I do this, I would get x to the negative 4. When I do this, I get 3 to the 4, x to the 4, y to the 8th. Okay. I can see x to the negative 4 plus x to the 4 is x to the 0. So these actually just cancel each other out. And I'm left with 3 to the 4th, y to the 8th. And 3 to the 4th is 81, y to the 8th power. Okay, again, x to the negative 4 plus times x to the 4 is x to the 0, which is just 1, and that's why I poofed them out. Here's some more examples. I can do this. I get c to the 6 here. Over here, I'm going to get 3 to the 4th, c to the 20, and now I can move this around to here. I can just move them by the commutative property of multiplication. This becomes 81 c to the 26th power. Okay. This one is a little harder, a little more. So we're going to distribute this in. And I'm going to get 2 squared, a to the 4th, b to the 6th. And when I distribute this in, I'm going to get 3 to the negative 2, a to the negative 6, and b to the positive 10. Because negative 5 times negative 2 is positive 10. Okay, so now when I do this, I'm going to move the 3 here. I get 2 squared times 3 to the negative 2, a to the 4th, a to the negative 6, b to the 6, b to the 10th. And this becomes a to the negative 2. This becomes b to the 16th. And I'm going to change this to a 4. But I'm going to leave this 3 to the negative 2 because I need to move it down. Okay, and I put the times there. And sorry, I'm going to move this so you can see it. Now I need to move this one down. And I need to move this one down. So when I go this way, I'm going to leave the 4 b to the 16th on the top. You can see that. And I'm going to move down 3 to the negative 2 becomes 3 to the positive 2, or 9. And then a to the negative 2 becomes a squared. Okay, so those are that was a little more involved, a little more depth to it, but it's the same properties that we're using. Okay, and the last one is scientific notations. I have 4 problems up here for you guys. So this is in the same way, because it's multiplication, I can distribute this in. Be careful, if it was 8 plus x squared, you cannot do this. That doesn't work if there's a plus sign. Okay, only if it's multiplication you can distribute in the exponents. Okay, so because it's multiplication, I can change it to 8 squared times 10 to the 8th power. This becomes 64 times 10 to the 8th. And again, remember I got to go this way. I'm going left, so I'm going minus 1, so I'm going to plus 1 here. So I go 6.4 times 10 to the 9th power. Okay. distribute this one in. 0.5 squared times 10 to the negative 12. 0.5 squared is 0.25. Be careful you don't go 2.5. It's 0.25 times 10 to the negative 12. And now I need to go this way. So I'm going to go plus 1 here. So I'm minus 1 there. And I'm going to go to 2.5 times 10 to the negative 13th power. Okay. This one I'm going to distribute in a 3 exponent. So it's 4 cubed times 10 to the 18th. 4 cubed is 16 times 4, which is 64 times 10 to the 18th. And you guys hopefully are getting better at this minus 1 plus 1, changing this. Okay, make sure if you're going left, you're minusing 1, so you got a plus 1. So I get 6.4 times 10 to the 19th. And then here's another one where I have another 10 to the 6th power in front. So I can just drop this one down for now, and I'm going to distribute this in, and I get times 2 to the 4th times 10 to the 32. And now I'm just going to move this over to the back to where the other times 10 is. So 2 to the 4th times 10 to the 32 times 10 to the 6. And now I can add these two exponents. So 2 to the 4 is 16 times 10 to the 38th power. And I'm going to go, from here I'm going to go left. So I'm minus 1 plus 1. So 1.6 times 10 to the 39th power. Okay. That is section 8.4. I hope this helps you guys.